It's newer in the US, so you might not have heard it, but it's a Perl backend. So I work in the backend team, which is based in Manchester, UK. Very nice city to live in if you're interested. It's also historically important for us techies. It's the first industrial city. It's where the first electronic stored memory computer was built, the University of Manchester's baby. And you might remember its successor, the Alan Turing worked on it, the Manchester Mark I, or for us Mancunian, it's the Mark I, right? Off to why optimize. So there are several reasons in no particular order. You might have application-specific constraints, like a real-time system that has to do some minimal work, or you want better scalability, like support more customers, more messages, more products. You might want a better user experience, like remove some lag from your app, make it more responsive, or if it's something that's through the web, have less of wait time. And you can have other increases in quality. If you optimize things, you can get, given a user's graphics, for example, you can send better graphic settings like okay. There's an important one is reduced costs. Like if you make something twice as fast, you need half the hardware or power, and it's faster development. If you compile faster, your test suite runs faster. You don't wait for things to run as you develop. And I should mention the oft-cited rules of optimization. You've probably seen this many times. First rule, don't. Second rule, don't yet. Third rule, profile first. You might also have seen this Knuth quote quite often. Premature optimization is the root of all evil. However, this is just part of the full Knuth quote, which is, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. So I would suggest some guidelines that are better than those rules. So consider the performance implications when designing your app. It depends on the requirements of the specific app. And be aware of and prefer efficient programming patterns. So build your code nicely, don't be lazy, but focus on code readability and maintainability. Don't spend effort in the small efficiencies that Knuth says. If your code is well written, you will be able to optimize later. And you will profile first. That's obvious because you might know Amdahl's law, or in general, you cannot optimize unless you know where the problem is in your code. If you try to optimize a part of the code that takes 1/1000th of the runtime, at best you can make it 1/1000th faster, so it won't help you. When Knuth was talking about small efficiencies, what could he be talking about is, this is an example. I found it quite interesting that the ampersand function calls are faster. So it's like you add the ampersand on the front, and I guess it doesn't have to search all the packages where the function comes from. So it's 15% faster. So 15% is like non-trivial as a percentage. Maybe we should add ampersand everywhere when we just removed it from everywhere. So when benchmarking, and this is a module that I use a lot including this presentation. So take note of the rate column. So this is, we're talking about, if you do the calculation, it's a 3 nanosecond gain, which is minuscule because you'll never call a function that does nothing. So if you add any, like a very small thing, like add 10 random numbers, right? This it goes away, then 3 nanoseconds is nothing. We'll want microseconds or milliseconds, even better. So just in case anybody has missed like the basics, the most popular profiler is devel NYT prof, and it's very simple how to call it. And you run NYT prof HTML to produce the report in nice HTML. It can also run under Apache if you want to. We still use Apache for historical reasons, and while our code obviously runs without Apache, so we can test it. And I still want to sometimes just follow a user journey, and I fire up a quick Apache with the profiler to replicate that without having to code it up. So I have like a convenient bashrc alias. It's a function. It just loads Apache on a single thread and with a compiler. You cannot do preload on Apache with the profiler. That's the only limitation. Anyway, the output is like this. You get your flame graph, you get your list of functions from the slowest to the fastest, and all the code per line, the timings, and the iterations. It's quite useful. So in general, when you write code, you have an idea about when you use an operation, you have an idea whether it will be slow or fast based on some generic tiers. Like if it's a network call, you expect it to be slow. It's the slowest tier of functions, I'd say. And there's a variance. You don't know exactly how fast it will be. File system I/O is the second slowest tier. Opening, reading files, loading modules, Perl modules, it's the same as opening and reading files. So it could take reach milliseconds if it's large enough or many files. Then we have memory I/O, which is commonly string manipulation because it requires copies of memory. And if it's a large structure, might be hundreds of nanoseconds. And the fastest are the regular CPU operations and memory lookups, perhaps. Okay. So moving down tiers is a very effective optimization strategy. And one way to do that is caching. For example, to avoid network I/O, you can reuse database handles. Each time you open a new database handle, you have to go to the database, come back, negotiate and come back. You can cache remote API requests to your local either memory or file system, depending on the size. You can cache frequent DB queries. At Spectrum, we use Memcached or GCP memory store for that. You can use cache control if it's web server, so the client doesn't even request things from you. You can avoid file system I/O, so going down a tier, and keep commonly used files in memory. A common example is if you have configuration files, don't just create a new configuration object every time to reread the files. Just have like a factory system to give you the same object again. You can preload Perl modules because if we load our app from scratch, all the modules, it might take over a second to start, like 2 seconds. So you preload it. We use mode Perl, so you can use it. You can do preload there, and it also shares the RAM because it loads in shared memory. So you save RAM as well. You just cache everything else that is complex to calculate. Example is templates. If you have like logged in users and non-logged in users, you can pre-render parts of the templates that are common for the class of users you are serving. You store expensive calculations in memory and use lookup tables. You store complex objects. On that, if you read the pod of CPAN modules carefully, they usually have ideas about that. For example, if you use the encode module, the slowest part of it is opening the encoding files for the encoding you choose. So if you have to encode like hundreds of strings to UTF-8 or from UTF-8, you create just one encode object and then you use it to encode, and it's several times faster. It depends on the length of the actual string, of course. And datetime tells you that you can speed up the creation of objects if instead of every time opening your time zone system files by declaring a time zone by the name, you can just cache the object that it creates and pass it on. So there's caching everywhere. So you already use caching in things like your CPU has the L1 to L3 cache to hold frequently accessed data. Your storage system might have, your storage controller might have a DRAM to store frequently accessed fetches. Your OS will use part of its RAM for buffers and caching. Your database system will do its own buffering depending on your setup, and if you rerun a query, it should be fast. DNS is cached because it's a network request, so at least your OS will cache it. Then you have proxies and CDNs, which reduce the network latency. We use Fastly. Another slow tier we said is file access. So try to improve your file access when reading a file. There are many ways to do it, and I benchmarked a few for you for opening Wikipedia HTML pages. And the general idea is avoid the while file handler, obviously, and use UTF-8 aware, like pathtiny, slurp, UTF-8 only when you actually need it. If your data is not, you don't need to encode UTF-8 data. It's much faster to do use other methods. And you can move the entire file system to RAM with a RAM disk, if a RAM drive. If you want, it's very easy to do in Linux. And it used to be much more popular back in the HD days, but it's still faster than SSD. Loops. So you should always pay extra attention to any kind of loop, because if you have n iterations, the code inside it is n times more critical than code outside. So nested loops increase that exponentially. So if you have something deeply nested, even something that's normally a small efficiency can become significant. Not all loops are obvious. Like the G modifier in substitutions is a loop, and I've seen this in code from people. Like they put a function in a substitution, and because it's like once there, they see it once. They think it's just one function call, but it's not. If there are multiple substitutions, so put everything you can outside the loop. And so since I said there can be deep loops, there are a few things that are normally small efficiencies that I will mention that kind of I've seen them inside deep loops. and, or like creating loops actually. So if you use the postfix, loop, the for loop, it's significantly faster enough that for non-trivial, work, like this is calculating, squares, it's, faster than, either the C style for or the for each style for. So you should always prefer it because it does not have to create a new scope. And, so these are very tiny normally, the or equal and, if defined equal. They're faster than, checking for if defined or if exists. And they look nicer. And I mentioned them because this was actually in, my first year in spare room. I saw this piece of code and, I just removed, like I made it into the, or equal, and I saved 0.2 milliseconds for every request on our website with that tiny change. It's because it was in the deepest loop we had for setting up the configuration object. And, so your ex, told me this the other day that it's similar. If you use, a refutil instead of checking for array, it's faster. And that's also something you might use for, setting up, checking many variables. So Perl hashes are great. They're fast. Use them to your advantage. So, for example, sometimes you have an array and you want to search it. It's often faster to convert it to a hash, despite the overhead, and, search the hash. So I have an example here. I search with first, which is, the list util first is the fastest way to search on an array to find something. And, I have a hash that's pre-made, or I create the hash using either a postfix for or a map. And the result is that the hash, if you already have the hash, is instant. If you have to create the hash, it's it's 2 times slower than a search on the array, or a bit less. And in general, it's a good rule. If you need to search 3 times or more, or do something with the array, seek the array 3 times, converting it into a hash is worth the overhead. And, the 3 rule applies even for, things like evaluating literal, conditions. I create this elements array with, either value, other value, rare value, or rarest value. And I'm trying to find the elements that have value, rare value, or rarest value. So I have 2, the compare optimized searches for the most common value first. So it will not have to go to the other 2, conditions if it finds it, which is the most common case. And, this one is a more random compare. Let's see. So the results include the creation of the hash. So for 3 searches, creating the hash and using it is actually faster than doing the conditions. And, it's always better to optimize the order of your conditions, as we can see. And you can be smart and write a very fancy regex that, will find everything you want and might look like, good for code golf. But remember that it will be, slower. Talking about regular expressions, avoid waste. So don't use dot star. Many beginners put it at the start or the end, which makes things much slower because there's a lot of backtracking. And, so use literal strings. They're fast to match wherever you can. Don't use the G or I modifiers unless you actually need them. Don't use, the capture parentheses for grouping. There's the actual grouping parenthesis. I know it's longer and uglier, but it's faster. And try to combine to make, fewer passes instead of multiple, rounds of regex, especially if your search string is very large. So I have a comparison test here. We're looking for Spain, and you can see the literal and the group searches are the fastest. If you start adding the other things, you slow down. The dot star is a killer. Substitutions are very slow operations because, well, depends on the size of your string, obviously, but they are potentially quite slow because there's a lot of memory copy. And you shouldn't use the substitution to replace the faster substring function, like searching for the last character. And actually, the last character is a bit faster even with chop and substring. It's a small difference. But yeah, don't use a regular expression to replace substring. Again, make the fewest passes possible for large strings. Sorry. I'm creating here like a mock template. By the way, all the code will be, it's on GitHub. We'll have a link so you don't have to like read all of it. And if I'm going too fast. So I'm trying to replace 3 placeholders with either like 3 passes or create a hash, and then I search for all of them at once, and it's faster. So it's the rule of 3. It's already faster. If you have more placeholders, it will be faster and faster because the time will be almost constant for the hash. So this has a big impact if you use big strings like HTML templates, for example. Unicode is much slower than single byte strings. That should be obvious because it's a variable byte encoding. And sometimes, even if your data is Unicode and you need to treat it correctly, you might still want to do something with that data that would not break if you operated on bytes. Like if you wanted to search for, that you're searching for Latin 1, like an ASCII string to replace it, or several, you can work directly on bytes. So while things like length, cases, or matches won't work unless you, in your match, you use the bytes themselves, the UTF-8 encoded bytes. It's sometimes worth doing the downgrade, doing your operations, even if you have to do the upgrade again. So this is an example, and it's even so it's several times, like 5-6 times faster if you work on bytes. It's still 50% faster if you convert. Oh, sorry. Yes. So the UTF-8 downgrade, according to the docs, modifies the data. It's almost, it's fast because the internal Perl representation is almost UTF-8. So, yeah, you only needed you could theoretically change the flag because of that, but that's riskier. I'm just wondering if they won't be corrupted as long as you know that while you're in that mode, they are the UTF-8 bytes, the C2 and A3, and yeah. If you have byte character that is not represented as a single byte, operation will fail. It will not fail. No. It will not fail. Downgrade will not fail. It will give you bytes. Yes, there is an option to have it fail, but I'm not using the option. So there is a UTF-8 character there. The first A has an accent. Yeah? Okay. So, yeah, for historical reasons in Sperum, our internal encoding is bytes. So we deal with that every day. But it does have the speed advantage. Anyway, so remember how reading UTF-8 files was slower. If you want to do something first that you can do in byte mode, read them in byte mode. So you then convert to UTF-8 when you have done all your functions. Quantization. This is, I'm referring to using quantizing keys for cache lookups, etc. I donate the servers for a project called 7Timer. It's a weather service. It's mostly relevant to stargazers and astronomers, and also it's used by Home Assistant. And there was a new client that was hammering the API, and it was like spiking the load, and I would need to buy a new server. So I was curious because requests are normally cached from what I had seen from the code. And it turns out the caching was on the actual request, and the client was sending like thousands of requests every minute with like slightly different long floats. And the weather service has a 20-kilometer resolution because it's based on GFS. So I had access to the code, so I changed the caching to be after rounding to 0.1 degrees, which is the minimum granularity. And that like removed 99% of the request from going outside the cache. And I mean, the client was still wasting time asking for the data, but we could return it fast, so the server was healthy again. It's a good idea to reduce network requests if you control the APIs. For example, the reason I support that project is because I make an iOS weather client. It's called Xasteria Weather, and if you're an amateur astronomer, you might know it. Otherwise, you wouldn't probably. But so in my app, it only requests data if you actually move 20 kilometers away, or it's later in the day. And but it uses two endpoints. One of them was very heavy, the Meteo endpoint. So since I could change the source code, I added a new endpoint, to combine the elements I wanted from Meteo, and I saved 2 seconds of CPU time per request, which is both for the user and my server. So the idea is don't be too strict about API design, like an endpoint cannot return combined data if you care about performance, and especially avoid API requests that depend on the previous one, for obvious reasons. Algorithms. That's actually since grad school, it's my main interest, algorithms. Don't suppose there's any SUNY Stony Brook alumni here? No. Okay. It's the algorithms lab. Good times. Especially for computationally intensive tasks. Do good research on the algorithm you'll use. And as many of you know, they are usually classed for complexity using the big O notation. Sometimes we class for size, like memory usage complexity. More often we use it for just time complexity because now we have a lot of RAM available. So the O1, it's the constant time. It's like a lookup table. It's an example of that kind of complexity. The second general fastest class is O log n. The logarithmic, it's a binary search on a sorted array is an example. ON, that's linear time. It's a linear search on an unsorted array is an example. ON log n is the quicksort as an example. ON squared, bubble sort, quadratic time. We're starting to get into slow algorithms. And you'll try to use lookup tables, binary searches, or even better, interpolation searches as much as you can, and other tree structures that are logarithmic or near. And because these are the examples of fast algorithms, and use them to your advantage. I will use an example from my last year's talk, since I have it ready. It's a 2D discrete cosine transformation. You see that there are two summations here, so that's 2 for loops already. And the equation is for just one point of a 2-dimensional matrix. So that's another 2 for loops. So overall, the naive implementation is a ON fourth power. And this is how it looks in Perl. And if I run it for a 92 by 92 matrix, it will take 8.8 seconds, which is good or bad, or I don't know. But note that if I didn't use the postfix style for, I would add 1 second to that. So that small efficiency matters there. So there are faster algorithms. Smart people have come up with better solutions. The fastest generic one, that's for any size matrix, is the ON to the power of 3. And this is how it looks like for Perl. And the same size matrix, it takes 100 times less time. It's 100 times faster. It's 2 orders of magnitude. So what about if we switch to compiled languages? As you might know, Perl is not built for compute. It's not its main strength. And neither is any interpreted or scripting language. So if we try the same algorithm for a bigger matrix, like a 256 size, so this is the faster algorithm, right? So now it takes 1.8 seconds with Perl. I tried Python 3, 1.3. They're doing a bit better there. And they improved a lot since Python 2. So how about a compiled language like Go? That's 20 times faster. Yeah, it's quite a bit faster. This is why, for things like that, you use C, inline C, or XS. And as you know, the Perl functions internally are written in C for that reason, because pure Perl is not fast, and many CPAN modules are XS modules. And this is my version of the XS. You can open the source code and at the end to see it. So it's faster than Go, because C is a bit faster. I expect it would be even faster if I used Fortran. There's a inline Fortran, but I haven't written Fortran in 25 years, and I really don't want to break that streak. Is the language more important than the algorithm then? So this is the naive C on the same size. So now it's 10 times slower than Perl. So the algorithm is the most important thing. The language is not. And if you have a lower complexity algorithms for a non-trivial size, it will always beat your compiled language choice. And CXS has overhead, so you're not going to get anything from converting a single or 2 lines of Perl code. And obviously don't try to rewrite the Perl functions, the core functions. And they're written in C by smart people. If you don't like to learn C, there's the option of the Perl compiler. And it's a subset, it's a restricted Perl compiler. And things get converted to C++ before being compiled. So it's like C++. You have to define the types of variables and function types. And I'm told there's a completely new version coming up soon. So that's one option. Parallel processing is the best way you can take advantage of modern computing resources. And Perl is a bit, it has various ways of doing parallel concurrent programming. We have Perl threads, although they're discouraged because they're heavy, and the suggestion is that to not even compile threads by default in Perl, because they might slow other things down. I've tested, and in modern Perl, it doesn't make much of a difference in non-threaded things. But yeah, you can see a bit of a difference. So you have fork, or even better, parallel fork manager. So it creates a child process, basically. It's a way to use processes, launch a new process, and you can split the workload with things like using modulo. We use that a lot for SQL. It works in all languages, including SQL. So we split things that way. You can use event-driven multitasking. I haven't used event-driven multitasking. I use MC, the Monicore engine, which is a queuing model, and it's very easy and convenient to use. You have various server worker applications like Apache ModPerl launches as many threads as you want. We use Gearman and Minion for async parallel jobs. And quickly on OO programming, usually benefits outweigh the performance overhead, but there is an overhead. Like when you do a new object, it's not the same as declaring a variable. And OO is not the right approach for every problem. And sometimes you might just be adding an overhead, either performance or either complexity without a benefit. And not all OO frameworks are made equal. Like Moose is slow. You should use Moo or Moose instead of that. Hopefully, Corina will bring us a modern OO framework that is also fast. Yeah, for Moose or Mouse, don't forget this. And creating objects is not free. You should have it always in mind. So sometimes in your code, it might be easy to say new user, even if you want a list of 1,000 users, when you should really have just fetched their names instead or something like that. So don't forget that objects can be heavy. I'll mention some slow CPAN modules here. Datetime, it's an amazing module, and it's slow for good reasons. It has like a sub-second accuracy and like it knows leap seconds and things like that. But you don't really need the capabilities for 99% of the time. And often you don't even need a calendar-aware function, which is what makes most time date functions slow. If you want to manipulate seconds, minutes, hours, instead of days, weeks, months, you really want timestamps. Many beginners don't realize that, and they convert from and back. Timestamps are just numbers. There are several alternatives to date time for parsing time. For example, I did a test. Usually, unless you're on Mac OS for some reason, POSIX is by far the fastest if it has a function available for you. And yeah, you can use timepiece, time local. SQL app. Oh, yeah, sorry.
I just wanted to mention, I've used POSIX. It's like basically the scan for the format.
Mm-hmm.
So it's like, so POSIX format is good for formatting time. I think it actually does a lot of
Mm-hmm.
interfaces with the system library. There's like the older stuff. So I tend to use that instead of the but there's another one. It's a separate module that you define the format, and then it will parse it from the string.
Okay. Okay. I ranted about SQL Abstract last year. So from my lightning talk from last year, I found out that in our code, we're passing a big list of message IDs to in so that the actual select is fast. So it took 15 milliseconds, and SQL Abstract took like a quarter of a second to create the SQL. There was a Princess Bride joke after this slide, but I won't repeat myself. So alternatives to SQL Abstract, use SQL Maker. It's faster. We use our own alternative in Spare Room. I recently released SQL Inserter for the inserts, which is based on our code. Even SQL Abstract Classic, it's fixed to an old version of SQL Abstract, and it's faster than the current one, but it's still slow. And you can go ugly SQL for big queries. So in my SQL Inserter module, there's a benchmark PL, and you can see how like SQL Maker is 10 times faster than SQL Abstract for inserting. SQL Inserter is over 40 times faster. Databases, they can be usually the slowest class of operations because they have remote network I/O and file I/O and computation, and a well-designed schema will go far to help you. And you want to make sure your developers are trained to the specific database you're using. For example, if you're using MySQL, you cannot take advantage of indexes by using OR in your where clause. Well, Postgres can at least do a bitwise scan there. And with Oracle, you'll be fine. You'll just be paying a lot. You can minimize network I/O by doing fewer queries. You can use multi-line inserts with SQL Inserter. It handles the buffer for you. And use the right database system. Don't put everything in your relational database. I will take some of my Q&A time because we had Q&A. We're using Sphinx for full text search, for example. That's very fast for that reason. BigQuery for big data. Know that DBIX class, while it's some people like it and I can see the appeal, it does have an overhead. I already gave a talk about test suites in the past. I will have a link for that. And some highlights is to use parallel, obviously, and preferably with test2's YAF. So run the slow tests first so you don't starve the parallel queues. Mock everything you can. Don't go through a web server. Use temporary DBs when you want, which are very fast, or a limited schema temporary DB if you must. Use a local DB server tuned for the test suite. And this is, after doing all that, our own test suite on a 22-core Sapphire Rapids server. It runs in about 3.5 minutes. If we preload modules with YAF, we reduce that to just over 2 minutes. It's 65% faster. If we use our test2 aggregate, which we developed, it goes to just over half a minute, 33 seconds. That's 307% increase for that. But we worked on it, so 93% of our tests run under aggregate, which is a module that doesn't fit all tests. Like if you have begin modules and there's a whole talk about that. You can link to that. RAM disk. I was over half a minute. I wanted to do less than half a minute. So I moved the data director of the database, which is the last slow thing, to a RAM disk. And now it's 25 seconds to run. Throwing hardware to the problem. You can make things instantly faster faster by throwing more hardware at it, right? So you can use faster SSDs to help with the disk issue. You can be careful in most cloud providers. The size of the instance defines the maximum IOPS or even network IO you can access. So you might want bigger instances instead of bigger and fewer instances. You can use RAM disks. Containerization will affect performance. Kubernetes will increase your resource requirements a lot. I'm running out of time, and a rough guide so I did a very big performance comparison over 10 providers with over 40 types of VMs to see which ones were good for our performance. And these are the generic tiers going from slower to faster. And usually, when you talk about vCPUs and cloud providers, if it's an Intel or an AMD, you're talking about a hyperthread instead of a core. Be aware that Intel hyperthreads are a bit slower than AMD hyperthreads. And there are some tips for maximizing performance. Look at my performance comparison by all means. So vCPUs are HT thread except a hyperthread, except the shared CPU instances who are not dedicated those, so they might vary in performance. And Google's Tau instance, the T2D, is a full AMD core. Highest on demand performance per price overall in cloud solution, I kid you not, it's Oracle's ARM A1. The big three providers are expensive for on demand. So you can find cheaper on-demand resources on Akamai node. For peak single-thread performance right now, you're looking for Sapphire Rapids or Epic Milan. And for peak multi-thread, it's definitely GCP's Tau T2D. It's Epic Milan without any hyperthreading, so you get a full core. And while cloud providers usually are a waste of money compared to having your own, you pay more. There is a case where they make financial sense. It's spot instances. You can get great deals using spot instances. And finally, some GCP specific tips. You can just define this variable to get a free speed bump of 30% if you use N2D instances, for example. They go from AMD Rome to AMD Milan. You can get a bump for N2 instances going to Ice Lake. And currently the T2D are the same price as N2D, will give you twice the actual physical cores. And the check spot prices because there are some amazing deals at times, especially the brand new Sapphire Rapids. It seems nobody's using them. So we can get a 22 core one for 0.086 per hour, which is not as much as we would pay for running the power on them, probably. And finally, if you need significant on-demand resources, you can use a third party that can give you reserved pricing on them because they have deal with GCP for free because they have 3-year commitments and they give you the price for 1 year, but for free for on-demand instances. We're using Doit's FlexSave for that. Saves a lot of money. And that's it. Sorry, I use the time for questions because we ran out.
Thank you.
Thank you.